Good day or good evening, wherever you are watching. This is Makiem Tutorials again, and still physics. We are here to discuss dimensioning of physical quantities. The first question that will come to your mind is, what is dimensioning? So let's go. Now, any quantity which can be measured in units of length, mass, or time, or a combination of two or more of these most basic quantities is said to have a dimension. Now, remember, length, mass, and time are the most basic of the quantities we have in physics. In my previous video, I talked about fundamental and derived quantities and units. If you have not watched the video, please, you see the link at the top right-hand corner. Click on the link. You can pause this one or stop this one. Go and watch that video, and then you continue with this, as this is a continuation to that video. Now, mass, length, and time are represented as m for mass, L for length, and T for time, respectively. So if you have any quantity that you can measure its units in terms of m or L or T or any two or the three of them, we say the unit has a dimension, or the quantity can be dimensioned. Example, volume is length times base times height. In that previous video, I told you all distances are represented with length. So it is L, L, L. You can see L is part of what I said here. So you have dimensioned volume. The dimension for volume is L to the power of 3. L to the power of 3. Dimensioning is as simple as that, but we will not stop here. Let's continue. Now derive the dimensions of the following. Force, which is mass multiplied by acceleration. Density, which is mass divided by volume. So let's take the first one. Force. Mass is not going to be dimensioned again because it's a basic quantity. So we leave this one as m. It is acceleration, which is a derived quantity that we need to dimension. Acceleration is defined as velocity divided by time. Let's continue. Now, acceleration is velocity divided by time. Time is a basic quantity, so you don't need to dimension it again. Remember, I said mass, length, and time are the most basic quantities. So when you are doing dimensioning, anywhere you see m, L, or T, you don't need to dimension again. Now, it is V that we want to dimension. Velocity is displacement divided by time. Remember, displacement is distance in a specified direction. So if velocity is equal to displacement, which is distance, divided by time, this has been dimensioned. Then acceleration is going to be velocity, that's L over T in terms of dimension, divided by time. Remember acceleration here. Velocity divided by time. So if velocity is L over T, so it's going to be L over T divided by T. That's why we have L over T divided by T here. Now, since it is L over T, it can be written as LT raised to the power of minus 1 according to the law of indices. And since this one is divided by T also, it is going to be written as T raised to the power of minus 1. Then we now have L T raised to the power of minus 1 multiplied by T raised to the power of minus 2. According to the laws of indices, it is going to be T raised to the power of minus 1 plus, let me put this in brackets, plus minus 1 again. So which is going to be T to the power of minus 2. So force, which is mass times or multiplied by acceleration, is m, that's mass that we had before, multiplied by LT raised to the power of minus 2, and this gives us the dimension for acceleration. Now, density is mass divided by volume. Density is mass divided by volume. Mass is in the last dimension already, so it's m, we don't need to dimension it, but volume is L times L times L. So let's continue. So we have mass divided by L into 3 places. So which is what? Mass multiplied by 1 divided by L into 3 places. Remember, 1 divided by L into 3 places is the same thing as L raised to the power of minus 3. So we have it as ML raised to the power of minus 3. It is this simple. So if there's anything you don't understand under this dimensioning, you can just write in the comment section and let me know so that I will address it. Okay, let's see. I have an assignment for you. Derive the dimensions of the following quantity: momentum, mass times velocity. Remember, you don't need to dimension mass again. It's velocity you need to dimension. Already in this video, I have the dimension for velocity. So you can just substitute and get your answer. Energy is work divided by time. Work is force times distance. You can dimension force. We already have the dimension of force. And distance is length, then divide by time. That is simple. Pressure is force divided by area. You can dimension first. We have the dimension there. And then area is length times breadth, which is length times length. So you can do that. I want you to do that and then drop your answers in the comment section. Thank you and bye for now. I'll see you in the next video. Thanks.